Hello everyone, welcome back. In this example, we're going to continue to talk about objects, and this time we're going to talk about images. So we'll do a few things for this example. We're going to do a few different variations on what we can do once we load an image. We're going to start very basic. We're going to just talk about loading an image, creating an image object, and then using it to simply draw an image. And then we'll dive in a little bit into the image object's methods, or remember the functions that are part of it. And we'll talk about accessing some of the data that the image contains, specifically pixel values, right? Colors. You can think of images as just a big collection of colors, and we can leverage that inside our programs to do all kinds of interesting things with the pixel values of images. Okay. So let's start with just first creating an image object. Now, the first thing we're going to need is we are going to bring in an asset file. We're going to add some kind of image file to our sketch. And for this demonstration, I'm using just this random JPEG that I found online. It's a picture of a lake somewhere. It's 1920 by 1080 in size, so it's quite large. But we'll just use that. Okay? And we are going to drag this over to the upload file box. And now that I've done this, I have a file here available for my program to use. Okay? So first step is actually just loading the image object. We are going to do this using a function called loadImage, and what we are going to get back from loadImage is a p5.image object. Okay, just to show you in the reference here, we're going to be using loadImage, and there's a bunch of image-related commands and objects. They're all available over here. So we're going to be creating a p5.image object using loadImage, and then once you have a p5.image object, there's all kinds of interesting things you can do with it. So first we're going to declare a variable to contain our object. I'm just going to call it img, short for image. Okay? And after we've done this, we are going to define the preload function. So we talked about preload in the previous video. What preload does is if you use one of the loading functions like load font, load image, load sound, these happen asynchronously, which means the return value doesn't wait for the loading to be finished. It kind of runs in parallel with the rest of the program. So what preload does is it makes sure that whatever you load inside it will be complete before the program moves on to setup. Okay? So we are going to use preload and then loadImage, put the resulting variable into our image, the resulting object into our image variable. Okay? And what that allows us to do is we can now use it to do any number of things. The most basic thing we can do with an image is we can feed it to the image command. So I'm going to say image, and then we give it a coordinate. So by default, images behave like rectangles. Okay, so the coordinate we give here is going to be the top left corner of the image. Okay? So we can see now we can only see the top left corner of the image, and that's because the image is bigger than I have room here in my window to display, right? If I make it larger here, we can see there's more to see. So that's fine. Well, these are a little bit long. Let's trim them a little bit because I want to make my canvas a little bit wider. There we go. Okay. So that's fine. So the image is large. Okay. The other thing we can do here with the image command is we can specify an actual size we want to draw the image at. Okay, so for example, if I put 100 by 100, this would take my image and squish it into a 100 by 100 square. Or, I could say width and height. Now, obviously, if I just do this, it doesn't take into account the aspect ratio of the image. Okay, this is not the point of this exercise. It will just squish it to whatever my window size is. Okay? But the point here is the image command allows you to specify both a coordinate and a dimension. We can also change the image mode, just like we can change the rectangle mode, and that changes what the coordinate means. Okay? So now this is the center, right, of my image, not the top left corner. And we could have this image follow the mouse by changing where we draw it. right? So now it's following the mouse, and we can make it smaller by, let's say, 10% smaller, right? The other thing we could do is, this size here is now dependent on the size of the window, right? We could make this dependent on the size of the image itself, right? So instead of width and height, let's open the p5 image here. So this is the object we're getting into our variable, a p5 image. And let's scroll down here, some documentation, and we'll see it has a few what's called fields or attributes. Okay, so it has a width, height, it has pixels. So our image has a width and a height property we can refer to. This is going to be whatever size, whatever dimension the image has. And it also has a bunch of methods, which we're going to explore some of them in this example. Okay, so these are things we can do with the image. Things like grab a specific pixel, copy it into like a region into another one, apply filters. There's different kind of standard Photoshop style filter you can apply to images and so forth. Okay, you can even load animated GIFs using loadImage, and these are some commands that manage the animation stuff. So back to this, what that means is that my image variable has a width and a height attribute. Okay, so I can access them using the dot, just like we've been doing. So the dot is, in object sort of terms, I think of it as like an apostrophe s in English, right? So this is the width variable of this particular image object. So we use the dot to connect these two things. So now this is using the original image width and height and then scaling that down to a smaller number. Okay? And of course, if we move, background to setup, we could use this to create a fun little, drawing tool with our image. So the first thing we can do, right, with images is load them. And then once we have an image object, we can pass it to the image function to simply draw as an image. And we're going to use that quite a bit when we build our game at the end to load all of the animation sprites and so forth. So very useful, obviously. Now let's build on that a little bit and talk about, kind of diving into the object and its functionality so that we, yes, can use an image simply and draw it as an image, but we can also do more interesting things like access individual color values inside that image and then build a program that uses that. And for this example, I'm going to rename this, or maybe I'm going to duplicate it, and just so I keep track of the different iterations. We're going to do 3 different iterations of this idea, starting with just drawing the image as is, and then we're going to write a little program that's going to kind of scan through the image and draw each row as these vertical lines of colors, okay, just to create an interesting effect. And then at the end of this video, we're going to just draw the image, kind of create like a pixelation effect as well. So let me duplicate this guy and rename this here so I keep track of it. We're going to call this image lines. Okay. And let's run it. Still good. Okay. All right. Let's bring background back into draw. Now, one thing we could do, right? So instead of drawing the image as an image, which is perfectly fine, instead we are going to go and use the get method. I'm going to click on get here. So get allows us to either get a subsection of an image, or if you just pass it a coordinate, it's going to give us a color, right? Kind of like a color picker. So if you give it an XY value, it's going to return an individual color from that image. So here's what I mean by that. If we were to say just draw the image, let's just have it fill the window here for now, even though it's going to squish it a little bit. Okay, and we're just going to put it back into the corner like so. We could grab individual colors, like kind of use a color picker if we use get. So for example, let's get the color that's under the mouse cursor. Okay? Now we have to be a little bit careful here because this is going to use the original image dimension. So maybe I'm just going to look at, let's get rid of width and height. Okay. And this is just the top left corner of the image, just to demonstrate. It's now going to map one-to-one coordinates into the image. Let's grab a color and then let's use it as a fill, and then let's draw a circle where the mouse is. Just to show that we can now look inside the image, and using the get command or the pixel array, we can access individual colors of that image, and we could then start to build examples around that. Okay. So for example, we could write a little bit of code that's going to use a for loop, go through all the top row of the image, right? Look at what color we find there, and then stretch it out, have it drawn as just a line, okay, just for fun. So instead of drawing the image here, we are going to write a for loop. It's going to go from 0 to width, or in fact 0, 0 to width. Okay. Let's delete this. And we're going to go and sample, right, individual pixels into our source image. So let's create a variable here. We're going to call x. We're going to map the counter. So the counter goes from 0 to width. We're going to map it to an index. Let's call it image x. Okay, we're going to map it to x coordinate that's going to be into our source image. So let's go from 0 to image.width. Okay, so first that's going to do the proper mapping here. And then let's grab a color. We're going to grab a color here. We're going to say image.get. And let's just look at the top row for now. And then we're going to use that as a stroke, and we're going to draw a line that's going to go from top to the bottom. Okay. Cool. So what we're seeing here is the top row of our image, the top row of pixels, right? All the colors just extended down to the bottom of the frame. Okay. Now we can make this interactive, the sketch, by using, maybe we could use mouse Y to select which row of pixels we are displaying. Okay, so let's do that. We're going to create a Y coordinate. We're going to map mouse Y. So mouse Y goes from 0 to height, but we want this to scan the full pixels in the original image. So we're going to map it to a number between 0 and image.height. And then instead of getting at image x0, we're going to get image x and image y. Okay. So now as I move my cursor down, I'm kind of like scanning through the image. You can picture it that way, changing which row of pixels I'm looking at, and then just drawing that as a series of lines, right? Kind of going in and picking individual colors from the image and then drawing it as a series of lines. So there's all kinds of really interesting creative ideas we can do with an image once we start to not think of it as its sole intended purpose, which is draw this image, but more rather as a kind of repository of colors, right, that have a particular order and structure inside them. So this is just one example. We could also kind of draw the full image, kind of do more of a grid approach, right? So instead of looking at the colors, one row at a time, we could look at the whole image, but then maybe draw it as something else than pixels, maybe like little boxes or little squares to kind of create a pixelation effect. And we're going to do that next. Let me duplicate this one again, and I'm going to save this as a different sketch. Let's call it image grid. So instead of going through the image, one row at a time here, we're going to write a little bit of code that's going to go through the entire image, right? And the way we're going to do that is by generating a series of pairs of coordinates. Okay, so a series of x and y coordinates. And we saw it before in previous examples. We can navigate a grid if we use a nested for loop structure. In other words, we're going to place a for loop inside another one, so that by the time the whole structure is finished, we're going to get all the combinations, right, of of x and y values using the two for loop counters. Okay. And here I'm using j because I'm already using I for this loop here. We're going to be careful here, make sure we match our curly brackets, and then we're going to indent this in a little bit. So the idea with the nested for loop, right, is that it allows us to kind of scan through something like a grid structure. So this will give us all the combinations of I and j starting from 0, 0 on the top left to width and height on the bottom right and everything in between. All right. So let's start by, we're just going to draw a point. Okay. This is going to be really, really slow probably, but just to demonstrate, we are going to draw a point at I and j, setting the stroke color. And then we're going to map, of course, we need to change this mapping. So this first one here is correct. So we're going to map I still to image X, and then we're going to map J to image height. Okay. So the idea here is that we're going to draw the image 1 pixel at a time. Okay. Except we're doing it inside these for loops, so it's going to happen right away. And it's a very inefficient way of drawing an image, but we're going to do something more interesting with that in a second. So I'm going to hit play here, and eventually we're going to see the image appear, but it's probably going to take a while because it's taking quite a while, in fact. Oh, there it is. Okay. It's going to take a while because what we're doing basically is we're drawing this entire image 1 point at a time here. Okay. So this is pretty slow. And I'm kind of regretting my decision here a little bit, but trying to stop the sketch. This is pretty slow, but there's a point to this, which basically is that we don't have to draw every single pixel in the image, right? We could skip some and then create an interesting effect where we selectively just draw some of the pixels. Did I succeed in stopping it? Still running. And I'm not sure I had it saved. Great. Let's just hit refresh and see what happens. Worst case, I will quickly go back to where we were. Okay, so drawing every single pixel, not a great idea. So instead, let's be a little bit smarter about this. So instead of drawing every single pixel, we're going to skip some. Okay, so instead of going in steps of 1 here, I am going to go in steps of, let's say, 20. Okay? And this should be a lot more manageable. And instead of drawing a line, we're going to go back and draw a point. Okay, so draw a point at I and j, which is our actual screen coordinate. Okay? And let's see what that looks like. Okay, so this is a lot less crazy. Now we're drawing, kind of jumping in steps of 20. So we're only seeing some of the pixels, not all of them, right? So there's a limit to how much stuff we can draw in a p5.js sketch before our computers start to struggle. And this was a good example. Okay, there's a lot of pixels in the screen, and you can imagine if you do 1 point for every one of them, it's pretty inefficient, and things will get slow. Okay? But in this case, we can play around with this. Now, instead of drawing a point, maybe I'm going to draw a square. Okay. And let's make that square also 20 pixels wide. And instead of setting the fill, the stroke, we're going to change the fill. Yeah. All right. So now what we're doing is we're saying, let's draw the image that we started with, but instead of just giving it to the image command, we're going to draw it by creating a grid of squares. And then for each square, we're going to sample in the original image, right, which color to use for that square. And then we can create this kind of like mosaic effect. Or we could draw them as, circles, knowing that this is going to be a little bit shifted, right, on the center. So we can start to reinterpret the image that way simply by reading its pixel values and manipulating them. We could also make this interactive. For example, the 20, right, steps and the 20 by 20 squares. Why don't we tie that to a variable? let's call that variable space. So instead of 20, we're going to put space, space, space. And now I can tweak that. I can go, you don't want to go to 1 because that's going to be really, really slow, but 10 is manageable, or I can make it, very blocky, right? Or make it interactive. Maybe we're going to map mouse X to fill that range, right? Allow us to play with that range. Okay? So now we can kind of interactively change the pixelation of our image, right? So kind of an interesting effect here. We could turn off the stroke if we didn't want to have a stroke there, right? Just have the pixels themselves. We're still seeing lines because of the rounding errors here. We could go and do floor, for example, and get rid of those rounding errors. So anyways, the point here is just to recap, is we can create objects that come with P5. So the image object is one of them. We saw string in the previous example. Typically, we'll load these assets inside preload, and then once you have your objects are basically these kind of like more advanced variables. They have a combination of data that they contain. So in the case of the image object, its data is all of the pixels in the image, and also the image width and image height attributes. Okay? In addition to that, right, they also come with functions. So the image object has a get function that allows us to sample individual colors inside the image. And it has a whole bunch more functions, which we're not all going to explore in this video, but the concept is the important concept is this, right? Objects are kind of a combination of two things, variables and functions packaged together into one bundle. Okay? All right, so I think that's it for the image object. We're going to do one more example this week, just to cover sound and audio. So just variation on the theme here. We're going to load a sound object and then build a little demo app with it. I'll see you in the next video for that.